Okay, so here are some more examples of logarithmic differentiation. So here's one where you must use logarithmic differentiation, because remember, this fits the form where we have x raised to a function of x. So this is in the form of like f of something like this, y equals f of x raised to the g of x power. And since the exponent and the base are both functions of x, there's no way to do this except logarithmic differentiation. So let's go ahead and take the log of both sides. The log of y should equal cosine of x times the log of x using the power rule. Cosine of x was the exponent, so we can write it as a product. And now this becomes a fairly simple implicit differentiation with a product rule. This is a multiplication sign, okay, not a minus sign. So with a product rule for the right-hand side. So I'm going to be thinking this is u, ln of x is v, and I'm going to real quickly do a u prime v plus uv prime. So u prime is going to be negative sine of x times ln of x plus cosine of x times 1 over x. So 1 over y times dy dx is negative sine x ln of x plus, probably move the 1 over x to the front. You could call it cosine of x over x. Either way is good. And then dy dx is equal to all of that times y. Well, we can, instead of writing y, we could just write x cosine x over here because this is y. Okay, so we can just write it in as the original expression when we bring it over. And that happens in all of these logarithmic differentiation problems where at the end you multiply everything by the original expression. Okay, so that one you had to use logarithmic differentiation. Let's do another one that would be just nicer with logarithmic differentiation. So let me change to yellow here. And this one is x plus 1 cubed times 2x minus 1 squared all over x squared plus 1 squared. Okay, so now just on the side, I'm going to jot something down. We're taking the log of an a times a b over a c. We can rewrite that as the log of a plus the log of b minus the log of c, right? So we're using both the multiplication and quotient rules for this. For the multiplication and I should say product and multiplication and quotient properties of logarithms. Okay, so moving along. We can rewrite this. The point of this is we can write the natural log of y is ln of x plus 1 cubed. So I'll write the 3 as a constant using the power rule as well. And then we'll have a 2 times the natural log of 2x minus 1. And then we'll have a minus 2 times the natural log of x squared plus 1. Okay, so you would have had a quotient rule with a product inside and everything, each of those pieces would in turn be chain rules. So this would be a nightmare to do the old way because you would have a quotient with a product, and inside of the product would be actually multiple chain rules. I think it's actually 3 of them that we would have to do. So pulling that apart would be incredibly time consuming, but doing it logarithmically is pretty quick. So we get 1 over y times dy dx is equal to 3 times 1 over x plus 1. Okay, and by the chain rule, the derivative of x plus 1 is just 1. So I don't need to write that. Plus 2 times 1 over 2x minus 1 times the derivative of what's inside of that, which is 2 again, because the derivative of this will be 2. And then we have minus 2 over 1, 2 times 1 over x squared plus 1 times 2x, because the derivative of the inside function is 2x. So let's just clean it up a little bit. 1 over y dy dx is equal to 3 over x plus 1 plus 2, plus 4. That is a 4 over 2x minus 1 minus 4x over x squared plus 1. You could get a lowest common denominator, but you don't need to. And now we're in the final step where we multiply everything through by y. So rewrite what you just had in parentheses. Times y, which was the original problem. Okay, so x plus 1 cubed all over x squared plus 1 squared. So that gets us to our answer. Okay, that was a lot faster than doing a quotient with a product with 3 chain rules inside. Okay, one final one is the following. Let's see, this one will involve a square root. All right, so we'll have the square root of 2x minus 1 over x plus 2. So let's take the log of both sides, ln of y, okay? By the way, this could have been done as a chain rule because we have a square root of something with a quotient inside. But let's see what happens if we do it logarithmically. So if we do it logarithmically, this is 2x minus 1 over x plus 2, all to the 1/2 power. This means we can apply our power rule and bring the 1/2 out, and then we'll have the log of a quotient. So we'll be able to use the quotient rule as well. We just have to be careful with our parentheses. Let's rewrite this first before taking the derivative. So we can rewrite this as 1/2 times ln of 2x minus 1 minus ln of x plus 2. Okay, now it's not that hard to take the derivative. You always get 1 over y dy dx on the left, and the 1/2 will stay, times ln of 2x minus 1 will be 1 over 2x minus 1, and we'll multiply by a 2 because that is the derivative of the inside. And then we'll have minus 1 over x plus 2, and that's just times 1 because the derivative of x plus 2 is just 1. And so there we have it. And so this side, almost there. See how this is a lot faster than a chain with a quotient rule. This will be 1/2 times 2 over 2x minus 1, okay, minus 1 over x plus 2. And then we just multiply by y. And when you multiply by y, it was the square root of 2x minus 1 over x plus 2. And there we have it. Okay, so you can see there's less to do in paper. If you know your rules of logarithms, you can pretty quickly get to an answer using logarithmic differentiation.